Question 25. The elements oxygen and sulfur are in the same group of the periodic table. Which statement about oxygen and sulfur is not correct? Oxygen and sulfur, they are in the same group in the periodic table, that is group 6. They are nonmetals. This one is correct. They have giant covalent structures. This one is wrong. Sulfur is S8. It actually has a structure like this in form of a W. So there is a sulfur here. There is one here, one here, one here, one here. It has many electrons, so the van der Waals forces of attraction are a bit stronger, such that it can keep it, such that they can keep it as a solid. So it has many electrons, and for nonmetals, the more the electrons, the stronger the intermolecular forces of attraction. Okay, and then these ones are in position to keep it as a solid. So this one is actually, this one has a simple molecular structure. Simple molecular. Oxygen is a gas. It also has the same simple molecular structure. Okay, so you cannot have a gas that has a giant structure. That cannot be there. So B is off. They have 6 electrons in their outermost shell. Yes, because they are in group 6. They react together to form an acidic oxide. This sulfur dioxide is an acidic oxide, or sulfur trioxide is an acidic oxide. When you react this with water, you get sulfuric acid. This one, sulfurous acid. So that is also correct. So the one which is wrong is B. So our answer here is B. Then question 26. Tennessine is at the bottom of group 7 of the periodic table. What are the predicted properties of tennessine at room temperature? Now, for group 7, we know that as you go down the group, they become less volatile. Fluorine is a gas. Chlorine is a gas. Bromine is a liquid at room temperature. And then iodine is a solid at room temperature. So they are increasing in the number of electrons as you go down the group. So that means the strength of van der Waals forces increases. Okay, so that is why they are in position to exist, like here as solids, then here as liquids, compared to these ones here. Okay, and this one here is a black. Sometimes we say dark gray solid. And then bromine is a brown liquid. Okay, brown liquid. This one is a pale green gas. But now they are saying tennessine is at the bottom. So if it is at the bottom, then the color, you can see that it keeps on intensifying. You cannot expect it to be brown or green or what. It has to be like black. So I have to choose from here. And it cannot be a gas. It has to be a solid. Okay, because for it has much more electrons compared to all of this. If iodine is a solid, do you expect this one to be a gas which is below it? It cannot happen. Okay, then what else do we have? Is more reactive than iodine, then more dense than iodine. I think this one is okay, more dense, because it has many more protons, and protons have gotten a mass. Okay, so this one has to be correct. More reactive than iodine, that is out, because for group 7 elements, these nonmetals, they react by gaining electrons. Okay, but then the distance here between the outermost electrons and the nucleus is too big. Okay, because it is too big, that means the nuclear attraction for the incoming electron is now weaker, and yet they are supposed to react by gaining that electron. So it is easier to gain that electron with these ones that have gotten a smaller atomic size, you get it, than these ones that are going down the group. That is why the reactivity of group 7 elements decreases down the group. But for group 1, because for metals, for them they react by losing electrons, it becomes very easy to lose this electron as you go down the group because of the decreased nuclear attraction. Then for group 1, for them they are more reactive as you go down the group because it is easier to lose the electron. You see that? So our answer has to be that A there.